مبدئيا نحب نرحب بwhoever اللي بيريفيو البرزنتيشن ده. احنا النهارده هنتكلم على sanitation والsafety of manufacturing of soft drinks, bottled water and ice. البرزنتيشن دي عبارة عن summary سريعة للشابتر اللي في الكتاب بالظبط. presented to you by أميرة وعليا ودارين وخلود ورشا وشدى وندى وياسمين and myself رويدة مهدي. طيب الشابتر ده بالظبط بنتكلم فيه عن ايه؟ بنتكلم فيه على 12 بوينت اللي قدامنا حاليا. احنا بنتكلم عن plant sanitation for processing and food services, quality, the requirement for processing, hygienical operations, sanitation standards for facilities, construction and repair of or equipment, FDA inspection for soft drinks establishments, sanitation, plant sanitation for food processing and food services, ice manufacturing, ground, buildings and facilities, cleaning and sanitizing of equipment and utensils. Okay, the first topic we're talking about today is plant sanitation for food processing and food services. We are going to include in this slide multiple points concerning food sanitation system, HACCP, and bottled water and standards on overall. Okay, food sanitation systems, it includes some stuff like good manufacturing practices and sanitation performance standards and sanitation procedures, but mainly they are the smallest legal requirement from any plant to produce a product under suitable sanitation system. Okay, then talking about the hazard analysis critical control points is currently not very needed from plants. It's only done from plants on their own initiative. The FDA doesn't require it in beverage manufacturing. Concerning the bottled water, FDA has issued a multiple legislations, including 21 CFR 110 and 129, which should specify whether the facilities or methods or practices and control using this processing, bottling, holding, or even shipping of water of drinking waters are in conformance with the GBA and required guidelines. Okay, at the end of the slide we have the definitions of lot, which is according to regulations it's a primary containers or unit that have the same size, type and construction that which are going to be shipped. Okay, in the next slide we have 2 points concerning the identity and labeling and the label statement. Okay, the bottled water is the water which has been sealed in bottle or other containers that are targeted for human consumption. It may have safe and proper antimicrobial agents as alternatives. Fluoride may be added if necessary, but only within the state limits of the beverages that can include water as an ingredient. But the ingredient list, it's excluded the water and carbonated water and disinfected water. But talking about the label statements, we have to cover some points. That includes that the food is referred on the bottle as bottled water or drinking water or one of the phrases. It's applicable to be maybe artesian water or purified water, mineral water, water that passes through U.S. pharmaceutical sterility, and water tapped from the aquifer through a hole dug, drilled, or otherwise built in the ground.
And now we are going to talk about quality. There are many aspects of quality for bottled water, as microbiological quality, physical quality, chemical quality, and radiological quality. First, microbiological quality. It must meet the standards of microbiological quality for total coliform and Escherichia coli. Second, physical quality. It should meet the following standards of physical quality. 1. Turbidity must not exceed 5 units. 2. Color must not exceed 15 units. 3. Mineral water is exempt from having allowable levels. 4. Odor must not exceed the threshold odor. Third, chemical quality. Bottled water must meet the standards of chemical quality and shouldn't have chemical substance in excess concentration. Analysis must be conducted to find compliance with levels of specified organic substance. Fourth and last, radiological quality. The bottled water shouldn't include the following: 1. Composite of radium-226 and radium-228 present 5 pci in per liter of water. Second, a gross alpha particle activity more than 15 pci per liter of water. Third, beta particle and photon radioactivity from manufactured radionuclides in excess amount. Fourth, uranium more than 30 mg per liter of water. Adulteration of bottled water is known by 1. Having a substance at level considered harmful to health, 2. Having in whole or in part any fleshy, rotten, or decomposed substance or that is unfit for food, 3. If E. coli is detected in bottled water. Bottled water should have the following allowable levels in known amount: 1. Inorganic substance, 2. Volatile organic chemicals, 3. Pesticides and other synthetic organic chemicals, 4. Certain chemicals where the Environmental Protection Agency has secondary largest contaminant level in its drinking water regulations. Mineral water is exempt from having allowable level, as exemption or pays the allowable levels and is not related to a health concern.
Requirements for processing. Plant construction and style ought to fit the subsequent. 1. The bottling area ought to be separated from different plant operation or storage area by tight walls, ceiling, and self-closing doors to guard against contamination. Number 2. If process operation area unit conducted in a part from a sealed system struggling, appropriate protection ought to be provided to preclude contamination of water and also the system. Number 3. Appropriate ventilation ought to be provided to decrease condensation in all of rooms. Number 4. The laundry and sanitizing of containers for bottled water ought to be happening in an inside area. Number 5. Rooms during which product water is handled, processed, or controlled, or during which container or instrumentation area unit washed or controlled shouldn't open directly into any area used for domestic household functions. Sanitary facilities. Each plant ought to have appropriate hygienical facilities as well as not restricted to the following: product water and operation water. Number 1. Product water. 2. Operation water. 3. Product water and operation water from approved sources. 4. Supply water distinct exemption. Air pins pressure. Whenever air struggling is directed at product water or product water contact surface, it need to be free of extraneous material. Locker and lunch rooms. When employee locker and lunch rooms area unit provided, they have to be separated from plant operation and storage area and should be equipped with self-closing doors. Hygienical operations. The merchandise water contact surface of all multi-service containers within the transportation, storage, etc. of product water needed to be clean and perfect alter. 2. Once improvement, all multi-service containers need to be transported and kept in such a fashion on assured rain and should be protected against contamination. Number 3. Single service containers and caps or seal need to be purchased and kept in hygienical closure till used. Before use, they have to be examined. Number 4. Filling, capping, closing, sealing, and packaging of containers ought to be tied a hygienical manner.
Unit package production code. Each unit package from a batch or a segment of a continuous production run of a bottled drinking water should be identified by a production code. The production code should identify a particular batch and the day produced as well as the type of the product being produced and the date produced. Filling, capping, or sealing. The World Health Organization recommended that all containers should be tested for a bacteria at least once every 3 months to ensure they are free of coliform organisms. A swab or RNS count should be performed once every month from 4 containers chosen just before the procedure is carried out. No more than one of the 4 samples may exceed 1 bacteria per milliliter of capacity or 1 colony per square centimeter of surface area. The performance of filler, cover, or sealer should be monitored during these tasks to ensure that the filled containers are sound, correctly capped, or sealed. Compliance procedures. The factory will examine the product sample as follows to ensure that its production of bottled drinking water conforms with the appropriate standards, law, regulations of the government agency or authorities having jurisdiction. If any coliform organisms are found, additional testing must be done to see if any of them are Escherichia coli. Record retention. All records and documented required should be maintained at the plant for not less than 2 years. All required documented should be available for official review at reasonable times. Soda beverages. The FDA doesn't provide a standard of identify for soda water. Many states have issued their own standard of identify. The information in this section has been compiled from the standard of identify by many state regulatory authorities and websites on food safety for state governments in this country. Standards of identify. Soda water is a class of beverages made by absorbing carbon dioxide in a bottled water. Soda water may contain optional ingredients including legal food additives or color additives. It may also contain buffering agents such as propylene glycol and ethyl glycerin. The Department of Health and Human Services doesn't approve the use of artificial flavoring in soda water.
So after that, I will talk about the sanitation standard for the facilities. First, the surrounding must be free from any substance that causes insect or rodent and can be easily cleaned. Building, birds and insect can be entered, and it is must allow for the expansion in the future. It must have locker, bathroom and process area. After that, the room should be designed separated from each other and should supply area for processing, receiving, filling, packaging and storage. Floor, the floor of the room in many factories should be easily cleaned and smooth. After that, the wall and ceiling away from the floor at the least 3 meters should be easily cleaned, should be anti-mold and fungi. The door and the window, it should closed outward, easily close. Window should not enter for the insect to the processing area or packaging area, and it should be glazed. After that, the light in the process and the packaging area shouldn't be harsh for the worker and shouldn't not be the source of the contamination to the ingredient. After that, the ventilation in the room should be the sufficient due to the prevent unpleasant odor. After that, the water supply. From the important principle, the unsafe water shouldn't be cross contamination with the safe water, and it should be approved by the state or the local author. Also, from the important standard of the facilities is the toilet facilities and the waste disposal. After that, the construction and the repair of the equipment, all the equipment, container, utilized and used in the handling, processing, compounding, mixing, storing, or the shipping beverage or the beverage component shall be smooth, impermeable, and corrosion resistance.
Now we will talk about FDA inspection for soft drink establishment. The processing, the first thing that we're gonna talk about is the determination of the time and returned bottle in the plant storage. Inflammable and returnable bottles should be washed as soon as possible after return. Determine conducted tests that applied in the incoming cans with spool and tops to check if the solvent was completely removed from the interior vinyl epoxy coating of the can. Now we're gonna have some confirmation of the bottle of the washing, mechanical brushing, and water pressures and temperature. We'll check about the soak time, the cleaning solution, and concentration of it, and its rising. First steps, we have like 11 steps or more. We have like minimize it into 11 steps only so you can understand it. First thing, we're gonna check the washer carefully while operating. Then examine the area and under equipment of the bottles at intake and end. Examine the empty, unable, returnable bottles or those containing foreign substances that are being introduced to the system.
Determine the period of the bottle washing solutions if they are changed and what procedures are taken to assure the proper wash solutions concentration. Determine the speed of the operated bottle's washer and efficiency of the rising. Determine the water pressure and efficiency and the number of the wash and the rinse sprays that are plugged. Check the uniformity of the wash and rinse and sprays with the bottle carriage. Sprays which are not uniform are not effective, even all the sprays are open. If the bottle washer is not working properly by using methylene blue, you can check for the months and discharge of the bottle washer. We're gonna talk about methylene blue and its tests in the later slide or the next slide. There's gonna be some tests about its steps. After that, we will check and examine if any mechanical handling or devices are operating properly. Describing foreign substances in the filled bottle and reject them either manually or mechanically. Test the washed bottle and pass for the filling. Describe any bottles observed to be in acceptable condition. After obtaining the permission from the factory, use the following steps with caution to avoid spilling the dye and plan for proper disposal. Put a funnel in the tester tube to be examined. Then add methylene blue solution that we talked about in these confirmations in the FDA inspection. We will add methylene blue and solution into the bottle about quarter to third the bottle capacity. Get rid of the funnel and place it into the following bottle to be examined. Turn the bottle so that the strain is spread over the internal surface of the bottle glass. Add the excess of methylene blue into the following bottle and wash the bottle with the water. Test the bottle after washing the blue color and retained. It will be retained. Repeat the steps in the next bottle. This cycle could be repeated for many times to check about if there is any contaminants, any molds, and so on. After that, collect the bottle that keeps the blue color as part of your garbage. You should dispose it. We will talk about the sanitation and the sanitary conditions that should be applied to the bottles. First thing, we will describe and examine the reason behind any excessive breakage of the bottles on the production line and the presence of the exploded bottles. Observe the filling operation for a period and estimate the time taken for the bottles that is exploded if the potential glass contamination is high. Determine if the bottle handling lines and the filling machines are covered to protect the bottles from broken glass from exploded bottles. Following the bottle explosion, you should control the glass by shutting down the line, cleaning up the glass, and examine the bottle for any traces of the glass. Then we will examine or we will apply some sanitary procedures on the finished product. First thing, we will examine the bottles for any particles by not agitating the bottle or returning it, as this causes carbonation bubbles, which may disperse small particles and make their positive identification difficult. In some cases, masses of molds may be found covering the entire surface of the bottle. This may be a result of the bent cap of inadequate seal, allowing the air to enter the bottle. Secondly, we will examine the contents of the bottle by disturbing them in the bottle as little as possible. This will lead to any sediments or particles on the bottom to rise 1 or 2 inches into the product. This can be of several substances, mold, yeast, ground dust, fibrous material from the plant material water treatment system, or other contaminants, as the ground dust and the fibrous material will appear as a very small as light colored particles. The yeast may appear as a light colored particle. Mold generally appear as a dark colored and irregularly shaped particles. If pieces of carbon are found, they will appear as a small dark particles as a result of water treatment system. What is the crown dust? The crown dust are bending chips fall from the crown hopper. This material can be found in and on the covers and the crowners, but it is not considered as a contaminant. Examine the bottle, then we will the following steps after we just define the crown dust. We will examine the bottom of the bottle for any possible sediments could be found. Identification of the small particle may be difficult while constructing some bottles that may require inverting for cannelling, as they can be distributed with carbonation bubbles. They can be differentiated as carbonation bubbles will rise and where contaminants will precipitate. Examine the cans and the non-returnable bottles. Cleaning procedures. So we will examine and clean the bottles and non-returnable bottles with the following procedures. Then we will determine if the wash cycle is completed and the cans or the bottles are air blown and vacuumed. Then we will determine if the syrup swirls are not confused with any contaminants. Finally, we will determine if the oil separation in the coolant products is not confused with any contaminants. If they are confused, and they will appear as a cream colored film, which disappear upon shaking, so that it will be difficult to determine if there is any contaminant.
Plant sanitation for food processing and food service. Labeling. Examine the product labeling to see if it conforms with FDA regulation. The FDA has provided the following guidelines for inspection of bottled water. Processing. You must do following. Number 1. Make sure the plant product operational water comes from approved source. Number 2. If the bottled water label contains a claim about water source, example spring water. Number 3. Examine the bottled drinking water containers, washing and sanitizing procedures. Number 4. Check to see if the product water treatment process or equipment is effective in preventing product adulteration. Sanitation. Number 1. Check to see if the plant is clean and sanitary. Number 2. Treatment for sanitization must adhere to minimum duration, temperature, or concentration requirement. Number 3. Filling, capping, and sealing operation should be inspected according to guidelines in processing for the FDA inspection of soft drink facilities. Quality standard. Minimum requirement are: Number 1. Test annually for chemical contaminant. Number 2. Weekly test for microbiological contamination. Ice manufacturing. FDA and packaged ice. Ice can be shaved, cupped, crushed, and can be made from tap water, from spring water, or purified water. But no matter the shape of the source, ice is considered as food by the FDA. Important definition. Number 1. Curing. Curing means pumping or removing a small amount of water that form in the middle of block of ice during the freezing process. Number 2. Ice. Ice the result of freezing water by mechanical or artificial means in any form. Number 3. Ice plant. Any company, including all essential apparatus where ice is created or processed, bagged, distributed, or offered for the wholesale for human consumption. Number 4. Ice vending machine. Any self-service equipment that can work without full-time service employee and behave as a stand-alone unit.
Now we will talk about personal sanitation. Number 1. Disease control. Any person, be illness or infected, should be excluded from any operation expected to result in such contamination and must inform supervisor. Number 2. Cleanliness. All persons working in direct contact with food contact surface, and food packaging material should conform to hygienic practice. There are methods for maintaining cleanliness to prevent food contamination, as wearing gloves, and their gloves used be clean and should be of an impermeable material, washing hands and sanitizing, removal accessories or any object may be fall into food equipment, storing clothing and other personal belongings far away from production and the cleaning area. Avoid eating food, chewing gum, drinking beverage, and using tobacco in production and the cleaning area. Number 3. Education and training. Personnel responsible for identifying sanitation failure or food contamination should have education and experience, or both of them, to provide a level of competence necessary for production of cleaning and safe food. Then we will talk about the ground, building, and facility. The ground around an ice plant under the operator control should be kept free from wastes and yard in good repair and dry. Should ice plant structure be appropriate in terms of size, construction, and design to make maintenance and sanitary operation in the food processing industry easier? The following requirements should be met by ice plant: required space for storage and processing, floor be sloped and clean, ceiling and walls easy to wash, illumination, ventilation, and windows and door. Water supply. Each ice plant have sufficient sources of water must be approved and applied all standardized. Waste disposal. All liquid wastes and rubbish should be disposed according to standardized. Plumbing should be sized, installed, and maintained to carry sufficient amount of water to required location. Use in transportable sewage and liquid disposal waste from the ice plant probably. Toilet facility. Be adequate, convenient, and accessible to employ at all times. Be simple to clean. All of toilet must be smooth and washable. Toilet not directly accessible from ice production or storage area. Doors of toilet should be closed automatically. Well ventilated. Window of toilet should be preferably screened. Toilet must be insect free. Paper soup individual toilet and the trash cans should be available, and each toilet room used by production employee should have approved hand washing sign posted. Dressing room and locker area. Designed room used for changing clothes and kept clean and in good repair. A sufficient number of lockers should be maintained clean. Personal locker shouldn't be found in area where ice is manufactured, packaged, or stored. Hand washing station. Sufficient number of laboratories should be available. Each toilet have hot and cold running water, soap, and approved sanitary towel or other hand drying device. If disposal towel are used, waste receptacle should be conveniently located near the hand washing facility.
Last but not least, I am going to talk about cleaning and sanitizing of equipment and utensils. Hand washing stations. A sufficient number of lavatories should be available. Each restroom should have hot and cold running water, soap, approved sanitary towels of other hand drying devices. Equipment and utensils. All ice plant equipment and utensils should be designed to be adequately cleanable, properly maintained, kept clean, and in good repair. All food contact surfaces should be corrosion resistant and should be made of non-toxic materials. Conveyor surfaces should be impervious materials. All equipment should be designed to prevent food contact surfaces from being contaminated by personal contact. The compressor used to supply air for water agitation should be designed to deliver oil-free air. Freezing tank covers of acceptable material should be designed and constructed to protect ice containers from splash. Production and process control. Process control. All operations in the receiving, inspection, transportation, segregation, preparing, manufacturing, packaging, and storing of food should be conducted following adequate sanitation principles. Chemical, microbiological, or extraneous material testing procedures should be used to find sanitation failures or possible food contamination. Raw materials and other ingredients should be inspected and segregated well. Warehousing and distribution. All product stored is to be refrigerated and should be cleaned to keep them free of contamination. The ice compartment vehicles should be of cleanable construction, in good repair, and refrigerated to keep them ice in a frozen state. Moreover, vehicles used to transport unpackaged ice should be constructed to be fully enclosed. Ice vending machine.
It must follow standard requirements, must be properly connected to approved water supply and sewage disposal facilities. Enforcement. A regulation agency needs approval for the following: when an ice plant is constructed, demolded, or when a structure is converted to an ice plant, proper specifications for such construction, remodeling, or conversion are needed. The specification should show the proposed layout, arrangement, mechanical plans, construction material of work areas, and the model number of proposed fixed equipment and facilities. Inspection of ice plants are performed often to ensure compliance.